I'm Wolfgang. I'm a research computing engineer at CIQ. Come with a background in biomedical research computing. Started my career as a virologist. So Greg already basically introduced Fuzzball, but just to reiterate, at the highest level, Fuzzball is a container orchestration tool. But it's built specifically by people who understand high-performance computing and typical workloads in high-performance computing for the types of applications that you're probably all familiar with being here at supercomputing. So it makes it lowers the barrier of entry to containerized high-performance computing. Basically, there's two components to Fuzzball. There's Fuzzball Orchestrate and Fuzzball Substrate. What Orchestrate basically is a Kubernetes appliance that bundles together all the things that you typically need to orchestrate workflows. So it includes a scheduler, it includes an orchestrate, which knows how to provision and/or allocate compute resources for your workflows. It manages secrets, it includes the databases to store historical data about your workflows. It manages storage, and it provides a user interface. Everything in Fuzzball Orchestrate is behind an API. So it's very API driven. There's an open API spec. You can generate your own software development kits and program against it. And all the tools that we write also use that API. So it's a first-class citizen. So in addition, so the API drives the command line interface that Fuzzball provides, as well as the web interface. The actual workflows run in Substrate, which is a container engine that you can think of in a lot of ways as Apptainer as a service. So it's a containerization platform specifically for high-performance computing. It knows how to do MPI. It knows how to natively access GPUs. And it's basically knows how to talk to Orchestrate to run large workflows. It provisions storage, it downloads and caches containers. And everything, and it does data egress and ingress to data lake if you have one. Now, Greg already alluded to it. One of the really nice things about Fuzzball is that you can take two Fuzzball clusters and federate them. So you can have an on-prem cluster where you set up your own Kubernetes, you run Orchestrate, and you have your own static compute resources, for example. And then you can have a cloud instance that does dynamic provisioning of compute instances. And you can put it all behind the same interface that you get with a single Fuzzball cluster. And then you can direct workflows to optimal places. While I'm here to talk about integration of Fuzzball with Nextflow, I also want to mention that the native sort of unit of execution in Fuzzball are workflows. Workflows are relatively simple data structures that you can write in YAML or JSON that basically define what resources jobs need, how different jobs in a workflow interact with each other. You can include services that persist. You can include services that are there for the life of a workflow and then go away. And then the actual code that they're running. So that's the typical unit of execution. And everything is containerized, so every job, every service that you define has to refer to a container image. And on top of that, as I mentioned before, on top of that API and what Greg talked about, the way users that are less experienced, that are maybe not Linux native, can interact with this is through the graphical user interface. Through the graphical user interface, you can follow along your work. Oh, sorry. You can follow along your work. You can follow your workflows. You have visibility in their log. You can see their logs. You can connect to the containers that they're running in. You can see results. You can start interactive applications. And there's a catalog of predefined applications that are essentially workflow templates. So users can start a workflow from the catalog, provide a few parameters to define their input files, parameters for the run, and so on. and then run either a workflow that we have defined and packaged with Fuzzball, or anything that you can pull in from a GitHub repo that follows a certain format. So that makes it very easy to just push new workflows to a GitHub repo, connect it to your Fuzzball, and they will show up in the workflow catalog. Okay, so do you guys have any questions about how Fuzzball works in a rough outline? Oh, okay. Nextflow. So one of the things about being a system that's specifically written to work well for HPC users is that we realize that there's a lot of other workflow orchestration tools that are very popular for a good reason. And Nextflow is one of them. And if you're here, then you probably know Nextflow already. Nextflow is an excellent tool. And it's made even more excellent because there's a large community of people that provide standard best practices workflows for all kinds of different analysis, very much focused on the biomedical space. And to make it easier for people to implement something like Fuzzball, we want to make it as easy as possible for people to keep using the tools that they like. And Nextflow is definitely a very popular tool that people like. And for example, if you have something like an RNA-seq pipeline, there's, depending on how you run it, 40, 50 steps. It would be wasted effort to try and rewrite something like this in the native Fuzzball workflow language. And that's why we made it, why we essentially implemented an executor for Fuzzball that you can keep using your Nextflow pipelines with Fuzzball. Okay, and that's basically the way this is possible, is because it's an API-first platform that allows you to easily write code against it. So the way we implemented this executor is by basically submitting the Nextflow controller job, and then it submits subtasks as workflows. And that's here's the link to the GitHub repo for this. Okay, I'm going to do a demo, but I'm not entirely sure how that's going to work with a microphone. Okay, so currently the way to submit Nextflow jobs to a Fuzzball backend. So basically let Fuzzball orchestrate your resources, but you keep using your pipelines. It's currently a command line submission, but I'm working on making this into an application in the application catalog. And the submission is really easy. There's a submission script that takes some options that tell Fuzzball how to run things, and then you just follow it with a fairly normal Nextflow command. So Nextflow, the only thing you have to do is tell it to use the Fuzzball profile, and it'll set up everything it needs to run Nextflow tasks as Fuzzball workflows. Okay, so this is what a Nextflow run would basically look like in Fuzzball. So Fuzzball has a notion of jobs, and there's also some stages where it has to set up storage, it has to pull containers. So the main Fuzzball Nextflow job pulls the Nextflow container, and a container it just uses for doing setup. Ah, it is. Okay. So this is basically, I'm looking at the same storage that was allocated to this particular job. So I have directories for Nextflow work directories, Nextflow output directories. And here's the run I did earlier. This runs RNA-seq. So if you're familiar with running Nextflow pipelines, this is pretty much exactly the same as if you were running it locally. You can get the normal output files. All the results are there. If you wanted to, you could set it up so that instead of, this was all using test data, so it's fairly small. If you're using larger data, you could have it pre-staged in your persistent storage on a Fuzzball storage volume, or you could have it ingress the data from an S3 bucket, for example, or anything that you can really, that you know how to pull down. You can have a setup job that pulls it with rclone from wherever your data is stored, or any mechanism that you guys use for ingress. And then it can store it in an ephemeral volume that gets deleted at the end, and egress the results. So I apologize for, I don't know why this is not, it worked right beforehand. Okay, so the basics of this is implemented. We're currently working on making the way it submits jobs more efficient. We're working on making a graphical interface to actually submitting the workflow itself, so you don't have to do it from the command line. And we're working on better interactions with remote storage.